Hello, so today we are going to continue on weekly contest 322. So the second problem, which is divide players into teams of equal skills. So what this problem says is that we have an array of skill that has length n, and n is even, the length is even. And basically skill I is the skill of the ith player, okay? And we want to divide these players into n divided by 2 teams or groups, where each team is of size 2, has just 2 members. And we want the total skill, which means just the sum of the skill of the 2 in each team, to be equal for all of the teams, right? And the chemistry is a different value that we want to return of these teams with equal skill is the product of the skill of the 2 players in each team, right? And so if we are not able to get this grouping of 2 in each team such that all of their skills is equal, then we're going to return -1. But if we can, we're going to return the chemistry using this definition of chemistry. I hope that makes sense. So in this case, for example, for this example, we can pair 1 and 5, right? So the sum is actually that we want all of them to be equal to is 6. We can pair 2 and 4, so the sum is 6. Good. Still equal. Condition is valid. 3 and 3, 6. And so that's all of the array. We divided it into groups of 2, and each of them has sum of 6. So it's valid. Now we calculate the chemistry, which is the product. So it's 1 multiplied by 5, which is 5. 4 multiplied by 2, which is 8. 3 multiplied by 3, which is 9. So 5 plus 8 plus 9, it's 22. So we return 22. So that's roughly the idea. Now how can we implement it? It's 10 to the power of 5. So this sort of tells us that, and also the length is even. So this sort of tells us that if we can solve it with sorting, the solution would pass, right? So let's see how we can do that. Well, the definite thing that is definitely given by this is that you can see each time we pair the smallest one with the largest one, right? The first smallest is 1, and then the second smallest is 5. And then we pair the second smallest, which is 2, with the second largest, which is 4, and then the remaining ones are 3 and 3, right? So that's actually the idea that we will do here, because we want the sum to be equal. And to have that with just 2 numbers, to have that possible, we have to pick smallest and bigger and pair them together each time, right? So that because otherwise, if we don't do that, let's say we pick the second smallest with the largest one, right? Then we are guaranteeing that the next sum would be bigger. The next sum would be not equal, because this one is bigger and this one is bigger, right? So we're gonna so that's sort of the reverse condition there. So what we want to do is sort the skill then, and then what we are going to do is just take the go through the range here of we only care, the length is even, and we only care about half, because what we are going to do, we only need half, right? Because we will pair each element, right, with, so 4. So we'll do only 2. For example, here the length is 4. We'll do only 2 steps, because in the first step we'll pair this one with this one, and then in the second step we'll pair these 2 here, right? So only a half, because each time we will do one from the first half and then one from the second half. So we will finish by when we do n divided by 2 operations. And so here we want the first and the smallest. So the smallest would be starting from I, right? Would be the skill at position I. And then for the other pair is from the other side, which is just n minus I plus 1. So n minus 1, right? This is the last position, and we want to do minus I, right? To subtract that. So basically it's n minus I, right? 1. Okay. So basically this one is the left one is I, and so the symmetry one from the other side, which would give us the next largest, is the one n minus I plus 1, right? So that's just n minus I minus 1. Okay. If this I think is not convincing, we can use a queue, and then each time we'll just pop from the beginning and pop from the right. Actually, maybe I'll do that first and then go back to this second. So first we can do is just get a queue of the skill. So collections.dq of the skill, and then we will pass the skill. And now we can just do this while there are elements. To pop the smallest one, since this is sorted, we will pop from the front. And to pop the largest one, we'll pop from the back, which is pop here. Okay, so let's call these maybe A and call this one B. But remember, what we are doing is we are dividing skill into groups of 2, where the sum needs to be equal. Okay, so what is this sum? Well, this sum is should be just the sum of the skill divided by the number of groups. What is the number of groups? The number of groups is, since we divide by 2 each, should be just the length divided by 2, right? So to get the sum that each group needs, we just divide this by that, right? So this is just divided by the group count, let's call it. Okay, this will give us the sum of each group, right? And then this is actually just this, right? Because each group has just 2. And so that's exactly what we're going to do here. So group count is this. We need n to be the length of skill. And then what we are going to do next is we are going to take S, which is the sum that we want every group to be equal to. So we want every 2 elements that will pop from the smallest and largest to be equal to this. If it's not equal, we want to return -1. That's what the problem says. So what we are going to do here is say that the sum of skill, exactly what we said here. So let's just copy it actually. Okay. Divided by group count. Okay. And now if this is different than that sum that we need, then we can't create it. Because they have to be all equal and there is group count groups, right? Okay, so otherwise, if they are equal, what we are calculating, what the problem says we want to calculate, sorry, let me just expand here, is the chemistry, which is the product of the skill of each group players, right? So how to do that? Well, we just need to initialize chemistry to 0. And we just need to do here chemistry plus A multiplied by B. And then at the end, we want to return it. That's pretty much it. So if we run this, submit, it passes test cases, right? In terms of time complexity, this would be, the queue would be at most the number of skills. So it's O(n) and is the length of skill. In terms of extra space, we are using this queue extra variable, so which is also O(n), so O(n) time, O(n) space. So that's just this traversing here, but we are doing this sorting here, so it's O(n) log n. So overall, this is bigger. So time O(n) log n and space O(n). DQ operations are O(n) from the front and back. Okay, so now that we did it this way, let's try to do it this way, which is doing the array, right? So that would be just like this. We still have the same thing here, except here we said we only need to go half, because each time we take 1 from each group. And so this one would be skill of I, and the second one would be skill of n minus I, and the rest is the same. Okay, so we still need to sort. So that passes as well. Now, since we still need to sort, this is still O(n) log n, and still O(n) space, right? Is it O(n) space though? No, we are not using really extra space apart from the skill itself, so it's O(n) space. So it's a little bit better. Okay, so this is a solution using sorting and the greedy approach. We can actually, if you, for example, in the context you didn't have this idea of doing this greedy sorting, you could do it differently, which is, let's just keep track of the available in a collection of dict. So let's just go through the skill, and what will available this do here is basically it will store any element that we've seen this far in the skill array. So let me show you what I mean. So let's say the skill here, what we'll have is this, right? And so available will traverse, so we'll find 3. And so we'll say, okay, we'll find 3 once, and then we'll go here, and each time we'll check. We know the sum that we need, right? We know the sum that we need for each group is this. And group count, we know that it's equal to n divided by 2, and we know that n is the length of skill. So we know the sum that we need. And so when we encounter a number, x, right? So before we had nothing. We want to check if s minus x, the desired sum here, minus x is already, we've already seen it in the list. If we've already seen it, that means we found 2 values that we can pair together as a group because their sum is s, right? And so, for example, here we will see, okay, what is s in this case? S in this case is 6, right? So we'll find 3. We'll check, is 3 in the available elements that we've seen so far? No, there is nothing. So it's false. So we just add 3 and we say that it's occurred once. So we increment. So basically what we'll do is we check if the available of s minus x is bigger than 0, which means it's in the available we've seen so far, then we can use it. So in this case, we want to do our chemistry, which should be equal to x multiplied by s minus x, because we are grouping these two together, right? But otherwise, we want to just add it so that later, if we find something that we can pair it with, we can do that. So here we'll do +1. Now here we used this, so we should mark that we used it by removing it, because we don't want to pair, let's say we pair 5 and then pair it again another time, right? So let's run this actually on our algorithm here. So we'll do 3 and we'll go to 2. Now 6 minus 2 is 4. We haven't seen 4 yet, so we add 2. We go 5. Have we seen 6 minus 5? 1? No, there is no key 1 here. The occurrence of 1 is 0. If it's not there, then it's 0, because we have default dict to int, and that will give us a value of 0. Okay, so we advance, but we also add 5. And now we see 1. 6 minus 1 is 5. 5 exists, so we can pair 1 with 5. So we add to our chemistry 1 multiplied by 5, which is 5. Okay, and now we remove 5 because, so we set it to 0. That's what this subtraction needs to do. And so we advance our pointer. 6 minus 3 is equal to 3. We have 3, so we pair these together. So 3 multiplied by 3 is 9. So we add it to our chemistry, and we set this to 0. We move on. 4. 6 minus 4 is 2. We have 2, and so we add 4 multiplied by 2, which is 8. So we're going to add that to our chemistry here. And we set this to 0. And now we are done. How do we check that we added every element to a group? We can just check available. If there is any element that has a value that is not 0, that means there are remaining elements that we didn't add to a group, so we return -1. So that's the idea here. And you can see with this, we got 5 plus 9 plus 8, which is exactly 22, the solution here, right? Now let's just do the rest here. So we said that if at the end we find any available x that is bigger than 0, which let's say at the end we had 2 that is equal to 1, then that means we didn't add this 2 here to a group, and so there is a problem. We couldn't add every element into a group, so we want to return false in that case. So if any of them for x in skill, then we want to actually here we'll just use available.keys because skill may be bigger, so we return false. You could also use for x in skills. It's -1. That's what the problem says we want to return. Okay, so let's just copy what we did here and add it here. And so this would be like this, and then we move it like this here with an else. And we here at the end we want to return chemistry. We want to return chemistry here. And we want to initialize it, of course. So chemistry equal to 0, right? Okay, so that's pretty much the idea here. Let me just make this shorter with this. And this is just the length of skills. Okay. And so we use this map here to keep track of the ones we've seen so far, and as soon as we see one where the complement of it that will make it sum to the desired sum is found, we use that, we add it to chemistry, and then we proceed. If we don't find a pair for it, we add it so that maybe later we'll find a pair, and we use this to find if there is if this is now possible. Yeah. So that's pretty much it. Now in terms of time, this is better in terms of time complexity because we are doing O of n time. We are not doing sorting, so it's just O of n time. In terms of space, we are using this extra variable here, which is at most O of n as well. So we are using O of n space, right? Yeah. So I think that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.